everybody and welcome to Invictus Elite Tuition, and today I'm going to embark upon a series of videos which are about quadratic equations and just encompassing everything that you need to know for your GCSEs. So today we're going to just go over some quadratic basics, those fundamental things that you need to know. We're also going to look at some methods for doing stuff, and then you're going to have a go at identifying the various bits that I've talked about in the video. So the first thing is I've put up a whole load of equations here, and you can see they go from simple things like y equals 3x plus 2 all the way through to y equals 3x cubed plus x squared minus 4. And I wonder, can you spot what is a quadratic in amongst all of these equations? What is the thing that makes some of these equations quadratic and some that do not? Well, the answer is, if I sort these, it's anything with x squared in it. So I've effectively got three groups here. You'll see the equation on the left is just 3x. The equations in the middle have got x squared in them, and the equations on the right hand side have got x cubed. And you might think, well, hang on, in that right hand column there's an x squared. But here is where we begin to define what a quadratic looks like. The thing here is that the highest power is 3x cubed. It's the x cubed bit, which means that this is not a quadratic. Over in this middle section, I've got 3x squared plus 2x. So does that 2x have anything to do with it? No, it doesn't. It's to do with the fact that there's an x squared there. I know it's a 3x squared, but it's x squared. So you notice that in this middle column, everything has got x squared in it. X squared, 3x squared, 3x squared plus 2x minus 4. I can now group anything that has got x to the highest power of being a square, and I can call that a quadratic equation. That is a quadratic. So if I've got x to the 4, x to the 5, anything like that, that is not a quadratic. And if I don't have anything to the power of x squared, then that's not a quadratic either. It's got to have x squared as the highest power. Now what I'm going to do is, down the left hand side of my screen here, I'm going to put a list of things that you need to take away as like key foundation things for a quadratic. The next thing is a thing called the quadratic equation, and this is a general quadratic equation, and this is in the form of ax squared plus bx plus c. Now I've coloured a, b and c because these are just numbers. What that means then is, if I see something like 3x squared plus 2x plus 4, then I can straight away say that a equals 3, b equals 2 and c equals 4. Now we will need this ability to take these numbers out of a quadratic later on in the series of videos. If I've got this one, well, there's no number in front of x squared, but why is that? Well, it's because basically in mathematics we try and keep the notation as easy as we possibly can, and so therefore it's actually a1, so it's a equals 1. Notice here b equals minus 3. We take the sign of whatever b is and make that the number minus 3, and c equals 2. What if I've got x squared plus 2? Well, you know from the previous slide that that's got to be quadratic because it has the highest power of x squared, but where's the x term in there? Well, all you've got to think about is, if I split that, then I think about what the general quadratic equation is. What would I have to put there? Well, I'd have to put 0x. There are 0 x's there, and I've actually just chucked in the 1 there to show that there should be a 1, but that would mean that a equals 1, b equals 0 and c equals 2. So that's the general quadratic equation, so we're going to capture that as well. The next thing is about factorising. Now, you actually know what this is about. This is stuff that you learnt about in year 5 or 6, but because we've brought it into quadratics, it appears more complicated, but it's not. Just follow me through my idea here. 6 times 4 is 24. Well, I'm going to change the notation a bit and put the 6 and the 4 in brackets. Then I'm going to change the notation even more, and I'm going to get rid of the multiply. But it's still going to be 6 in a bracket multiplied by 4 by a bracket. What do we call 6 and 4? What do we call these numbers when they're paired together? Well, they're a factor pair. 6 and 4 are the factors of 24. Now let's make it look a bit more algebra-like and a bit more what we know about quadratics. If I said x equals 1, well, what I could do is, instead of having 6, I could have x plus 5, because x is 1, 1 plus 5 is 6. Do you see where I'm going on this? And x plus 3, that's 4. This looks like this bracket expanding thing that you may have seen before, but the key thing I want you to know is that if I have factors, which in quadratic equations are going to be looking like, it's the shape of it, two things in brackets, then if I multiply those together, just like I would multiply two numbers together, then those are a factor pair, those are factors. They produce a quadratic, and that will follow the rule ax squared plus bx plus c. And we will look at that later, but I just want you to know that that's what factorising is, breaking that quadratic down into two simple terms in brackets themselves. Now what do we call that? We call that expanding a bracket, don't we? We expand x plus 5 and x plus 3 and we would get our quadratic equation. We'll look at that a bit later on, but I want you to have that notion of what we're doing here. And in fact, if I put it like this, we can say that if we've got two brackets, we expand a bracket, then we would get a quadratic. And if we take that quadratic and we factorise it, just like two factors of 24 would be 4 and 6, then we get these two bracketed terms here. Next thing I want to have a look at is solving, because we hear people talk about, and we see questions with factorising and solving. We've covered what factorising is, breaking the quadratic down into two bracketed terms, and we've explained what expanding a bracket is, but what's the solution? So the simplest way I can show this is I've plotted three quadratics. This first quadratic crosses the x-axis in two positions. The next quadratic crosses the x-axis in one position, and my final quadratic doesn't cross the x-axis at all. That means that when we solve a quadratic, we have either two solutions, one solution, or no solution. It all depends on how many times it crosses the x-axis. And the other thing that I would want you to notice here is this general quadratic shape. In this particular case, it's like a happy smiling face, and that's what a quadratic looks like. It's this curve shape, and again we'll talk about that in later videos. So there we've got it. A quadratic equation has a highest power of x squared. The general quadratic equation is x squared plus bx plus c. We can break that equation down by factorising to get two things in brackets, or we can have two terms in brackets and expand them to get the quadratic, and we've got solving. I want you to know those 5 things. Those are key foundation stones for you for moving forward with your understanding of quadratics. Now it's your turn. I would like to know, is that a quadratic equation? But the answer is yes, it has to be, because it's got x squared as the highest power of x. How many solutions does that quadratic have? Well, it's got two solutions because it crosses the x-axis in two places. Is this equation a quadratic equation? No, it's not, because it's got x to the power of 3 in it, and a quadratic has the highest power of x squared. And how many solutions does this have? It has no solutions. Okay, thank you very much for watching through this video. Look at the videos that are going to come after this, and you'll get an absolutely fantastic grounding in quadratics for your examinations, your general maths understanding, and also for your GCSEs. And I'm popping up a couple of videos here that you might find useful in your further mathematics studies. If you've enjoyed the video, please like and subscribe.